Such information is available in a much smaller part of the time than it was previously. So, I think many of the records we currently have about the universe are actually going to be broken soon. The excitement around how massive these new discoveries are is palpable, especially being here surrounded by researchers, astrophysicists, and cosmologists who truly understand how these new findings are changing our perspective on the universe. They recently discovered something exceptionally strange about the universe. Unusual things were seen in new images from the James Webb Telescope. This demonstrates that there were strange phenomena in existence before the Big Bang. Notable researchers from all over the world are now warning that these findings could make us question what we assume we know about the universe. Einstein said that the world resembles a bubble, and we live on the outer surface of it. He proposed that the universe is a bubble, and we live on the skin of this bubble, which is expanding. This is referred to as the theory of cosmic inflation. String theory suggests there are other bubbles out there, like a cosmic shower of bubbles. Big bangs are happening at this very moment, implying a multiverse with an endless array of universes. Therefore, there was something before the Big Bang, an ongoing bubble shower of universes. So, the model is unlike the traditional Big Bang theory, where something appears from nothing and then fades back into nothingness, correct? No, it's more complex. The Big Bang was not the true beginning as we perceive it. The universe evolved after the Big Bang, which led to the formation of the first stars, galaxies, and black holes. Yet, there's still a fundamental question. What was there before the Big Bang? Scientists are stunned, thinking they may now have an answer. The Webb telescope's results indicate that there might have been something unusual in the universe before that event. These findings suggest gaps in our current models of the universe. What did we discover, and why did it shock scientists around the world? In the 1920s, when researchers observed distant galaxies for the first time, they discovered something astounding. Galaxies appeared to be moving away from us. Initially, this led some people to believe Earth was at the center of the universe. However, further studies showed that some galaxies, like Andromeda, are moving toward us, although most are receding. This puzzled astronomers until they finally understood that space itself is expanding, not the galaxies. After years of careful experiments and observations, we now know that this expansion isn't as straightforward as it seems. It has no center. This means that no matter where you are in the universe, everything appears to be moving away from you. It's as if every point is the universe's center. Because of this discovery, we now understand that the universe doesn't have a proper center. Everything is expanding, which means that everything is moving away from everything else. Researchers have observed that space isn't just growing, but it's also accelerating. This implies that galaxies farther away are receding from us faster. New studies show that 97% of galaxies visible to us are moving away at speeds faster than light. One of the most essential principles of physics states that nothing can move faster than light. So, how can this be? To understand this, you need to consider Einstein's theory of special relativity. Light is considered the fastest thing that can travel through space. However, as I mentioned before, galaxies far away aren't moving away from us through space. Instead, more space is forming between us and them because space itself is expanding. The distance between us and these galaxies is growing faster than light can travel. This means it's not the galaxies that are moving faster than light, but rather space itself is pushing them along. Researchers believe that the Big Bang may have been the beginning of this expansion of the universe. Before the Big Bang, we didn't have space, time, or matter. The Big Bang marks the beginning of our universe, as well as the introduction of space-time. There was a massive explosion that created the universe, which grew from a tiny, hot point into the vast space we see today, filled with stars and galaxies. When we talk about the Big Bang, our standard model of the universe suggests that, around 13.8 billion years ago, this singularity would have been the size of Texas, containing the entire observable universe and everything beyond that we cannot see. This singularity wasn't a single point in space as you might think if the universe had an edge. However, if the universe is indeed infinite, it has always been infinite. In other words, the Big Bang happened everywhere in space, not just in one spot. This means the first galaxies didn't form in just one area, they formed throughout the universe, even in places we can't see. Matter seemed to appear everywhere simultaneously. While the Big Bang explains certain things, it doesn't explain why the universe is flat and evenly spread out, nor why it looks the same in every direction. This is where the idea of inflation comes in. There is evidence that the universe expanded almost instantly just before the Big Bang. This is called inflation. It went from being incredibly tiny to much larger in less than a trillionth of a second. An unusual type of energy in empty space caused this rapid expansion. That said, this empty space wasn't truly empty, it was filled with a unique energy that caused space to expand at an astonishing rate. Many people imagine the universe expanding into an existing space, but before inflation, the universe was a cold, almost empty, dark void with no particles or stars. However, this void contained an energy that made the universe expand. Any bumps or irregularities in space were smoothed out during this rapid expansion. This is why, when we look at the universe on a large scale today, it appears flat and uniform. All the energy stored in space was released when inflation stopped. This sudden release of energy heated everything up, sparking what we now call the Big Bang, a hot, dense explosion that filled the universe with particles, light, and everything needed for galaxies, stars, and planets to eventually form. This tells us that before the Big Bang, the universe was a cold, empty space that quickly expanded due to this strange energy. The concept of inflation also explains why the universe appears the way it does. Everything that followed this expansion built on top of it. However, while inflation provides answers to some of the biggest questions, it raises new ones, such as why this inflation started and stopped, and what was this strange energy that drove it. But we are talking about the entire universe, and there's nothing outside it that could have triggered this. More questions have been raised by discoveries from the James Webb Space Telescope. These findings suggest that strange things existed even before the Big Bang. It was a surprise to find that the universe is expanding at different rates in different directions. Scientists previously believed that the expansion of the universe was smooth, making this a significant discovery. The idea that the universe rapidly expanded before the Big Bang due to vacuum energy is supported by the theory of cosmic inflation. This theory also suggests that development ought to be the equivalent all over the place. These new outcomes from the Webb telescope, however, make us question what we assumed we had some awareness of expansion and make us wonder why the universe is expanding in different ways in different places. Is this lopsided development brought about by something other than dark energy? Dark energy is believed to accelerate the development of the universe, yet new data from the Webb telescope suggests that there may be more to it than we think. It's possible that an unknown force is altering the way space expands in all directions. Researchers using the Webb telescope have observed thousands of odd red specks in the deep field images it captured. Initially, they thought these might be galaxies far away, but they have strange features that don't fit what we know about early galaxies from our models. These objects behave in ways that are difficult for us to understand, which suggests there may have been other kinds of objects in the early universe that we have little insight into yet. They are significant because they show that there was something there before the Big Bang, and that something very unusual may have happened before the universe we know today began. Why did you choose to take a closer look at that one? In the very first data we received almost a year ago, we saw this object. What surprised me most was how bright it was. At first, we thought it couldn't be that far away since it was too bright. We gathered better data, including spectroscopy, which made it clear that this yellow mass is the farthest galaxy we have ever seen. Nobel Prize-winning scientists and other experts now say that we may be missing a significant piece of what we think we know about the universe. What happened before the Big Bang isn't fully explained by the standard model of cosmology. It only talks about how the universe changed after the Big Bang. New observations from the Webb telescope suggest that there may be more to the story. These observations point to something that may have occurred in the cold, empty space before the universe expanded. The standard theory of expansion says that the Big Bang was caused by a burst of rapid growth fueled by vacuum energy. These new findings call that theory into question. There are signs that the universe is expanding at different rates in all directions. If this smooth, uniform expansion truly shaped the universe, why are we now seeing these anomalies? It makes us think that there might have been something more complicated happening before the Big Bang that influenced the universe in ways we're just beginning to understand. Besides these strange expansion patterns, the Webb telescope has also found unusual objects in the early universe that don't fit into our current models. These results suggest that the early universe may have contained more types of matter and mysteries than we previously considered. This evidence implies that the Big Bang might not have been the beginning but rather the start of something else that we still don't fully understand. Scientists are increasingly open to the possibility that our current theories may need significant changes as they continue to study these findings. If there was a period before the Big Bang when the universe was shaped by different forces or conditions, it could completely change our perspective on cosmology. Thanks for observing.